The moon has captivated humanity since we first gazed upon its celestial glow. Its silvery light has inspired countless poems, songs, and stories. For centuries we have marveled at its phases, from the slender crescent to the full, radiant orb. Yet, the moon harbors a secret, a side forever hidden from our view. This hidden hemisphere, often called the dark side, is shrouded in mystery. It has fueled our imaginations, giving rise to countless myths and legends. The term dark side is, in reality, a misnomer. The far side of the moon is not perpetually shrouded in darkness. Like its Earth-facing counterpart, it experiences day and night cycles. The difference lies in its orientation. The moon is tidally locked to Earth, meaning that it always presents the same face to our planet. This is due to gravitational forces that have synchronized its rotation with its orbit. As a result, one hemisphere of the moon is always facing us, while the other remains hidden from view. So, while the far side is not perpetually dark, it is perpetually hidden from our direct gaze. This fact alone was enough to spark countless speculations about what might lie hidden on its surface. Some imagined it to be a desolate wasteland devoid of any features of interest. Others envisioned it as a breeding ground for strange and exotic life forms. The truth, as we would later discover, lies somewhere in between. The far side of the moon is indeed a different world from the one we see from Earth. It is a world shaped by billions of years of cosmic bombardment, where towering mountains cast long shadows across vast plains of ancient dust. One of the most striking features of the far side of the moon is its rugged and heavily cratered terrain. Unlike the near side, which is characterized by vast dark maria, the far side is dominated by ancient highlands and a seemingly endless expanse of impact craters. These craters are a testament to the moon's violent past, a time when it was constantly bombarded by asteroids and comets. Each impact left its mark on the lunar surface, creating a landscape that is both beautiful and awe-inspiring. Some of these craters are truly colossal in scale. The South Pole-Aitken Basin, for instance, is one of the largest known impact craters in the solar system, stretching over 2,500 kilometers in diameter. Its sheer size is difficult to comprehend, a stark reminder of the immense forces that have shaped our celestial neighborhood. The far side's cratered terrain also holds valuable clues about the early history of the solar system. By studying the size, distribution, and composition of these craters, scientists can piece together a timeline of the bombardment events that shaped the moon, and by extension, the Earth. In January 2019, China achieved a historic milestone by becoming the first nation to successfully land a spacecraft on the far side of the moon. The Chang'e 4 mission, named after the Chinese goddess of the moon, marked a new era in lunar exploration. The mission consisted of a lander and a rover, both equipped with a suite of scientific instruments designed to study the far side's geology, mineralogy, and environment. The landing site was carefully chosen to be within the von Karman crater, a relatively smooth region within the much larger South Pole-Aitken Basin. This location offered a unique opportunity to study some of the oldest rocks on the moon, potentially holding clues about the lunar interior and the early solar system. One of the key objectives of the Chang'e 4 mission was to study the composition of the lunar regolith, the loose, dusty material that covers the moon's surface. The rover, named U-22, was equipped with a ground-penetrating radar that allowed it to probe beneath the surface, revealing the layered structure of the regolith. Section 5. Unraveling the secrets of the lunar surface. The Chang'e 4 mission's findings have provided scientists with a wealth of new information about the far side of the moon. The rover's instruments detected the presence of minerals such as olivine and pyroxene, which are thought to originate from the lunar mantle, the layer beneath the moon's crust. This discovery supports the theory that a giant impact early in the moon's history excavated material from the mantle, scattering it across the surface. The mission also shed light on the nature of the far side's subsurface structure. The ground-penetrating radar revealed the presence of multiple layers of regolith, each with its own distinct characteristics. These layers likely represent different periods of impact history, with the oldest layers lying at the bottom. Further analysis of the data from Chang'e 4 is ongoing, and scientists are eager to unlock more secrets hidden within. The mission's success has paved the way for future exploration of the far side, and plans are already underway for even more ambitious missions. Section 6. the possibility of lunar water. One of the most tantalizing discoveries in recent years has been the detection of water ice on the moon. While the presence of water on the lunar surface was once considered highly unlikely, observations from multiple missions have confirmed its existence, particularly in permanently shadowed craters at the lunar poles. These craters, which never receive direct sunlight, act as cold traps, preserving any water ice that might have accumulated over billions of years. The far side of the moon, with its more extensive and deeper craters, is thought to harbor even larger reserves of water ice than the near side. The presence of water on the moon has profound implications for future lunar exploration. Water ice could be a valuable resource for future human missions, potentially providing drinking water, oxygen, and even rocket fuel. Extracting and utilizing lunar water could significantly reduce the cost and complexity of establishing a permanent human presence on the moon. Section 7. The Moon as a window to the cosmos. Beyond its potential as a resource, the far side of the moon also holds immense promise for scientific research, particularly in the field of radio astronomy. Radio astronomy is the study of celestial objects that emit radio waves, a type of electromagnetic radiation that can penetrate the Earth's atmosphere. The Earth's atmosphere blocks many radio wavelengths, making it difficult to observe faint or distant objects from the ground. The far side of the moon, however, acts as a natural shield against radio interference from Earth. This radio quiet zone offers astronomers an unprecedented opportunity to study the universe in a way that is simply not possible from our planet. Section 8. A sanctuary for radio astronomy. Building a radio telescope on the far side of the moon would allow astronomers to observe the universe at wavelengths that are currently inaccessible from Earth. This could lead to groundbreaking discoveries in a wide range of astrophysical fields, from the study of the early universe to the search for extraterrestrial life. One of the most exciting possibilities is the potential to detect signals from the cosmic dawn, the period shortly after the Big Bang when the first stars and galaxies began to form. These signals are extremely faint and are easily drowned out by radio noise from Earth. A radio telescope on the far side of the moon, however, could potentially detect these faint whispers from the early universe, providing us with unprecedented insights into the conditions that led to the formation of the cosmos as we know it. In addition to studying the early universe, a lunar radio telescope could also be used to search for technosignatures, signs of technology produced by extraterrestrial civilizations. Section 9. Future missions and the quest for knowledge. The far side of the moon, once a realm of speculation and mystery, is rapidly becoming a prime destination for scientific exploration. Multiple space agencies and private companies are planning future missions to the lunar surface with a particular focus on the far side. These missions will build upon the success of Chang'e 4, carrying even more sophisticated instruments and rovers to further unravel the moon's secrets. One of the key goals of these future missions is to search for and characterize water ice deposits in more detail. This will involve sending rovers to permanently shadowed craters at the lunar poles, where they will drill into the surface and analyze the composition of the ice. Understanding the distribution, abundance, and accessibility of water ice will be crucial for planning future human missions to the moon. Section 10. The Moon's enduring allure. Another priority for future missions is to establish a long-term human presence on the moon. This could involve building a lunar base either on the surface or in orbit that would serve as a hub for scientific research, resource exploration, and even tourism. The far side of the moon, with its radio quiet zone and potential for water ice resources, could be an ideal location for such a base. The lessons learned from establishing a permanent human presence on the moon could then be applied to even more ambitious missions, such as sending humans to Mars and beyond. The moon, our closest celestial neighbor, continues to beckon us with its allure of discovery. The far side, once hidden from view, is now revealing its secrets, offering us a glimpse into the moon's ancient past and the vastness of the cosmos. Section 11. Conclusion. As we continue to explore the moon, we are sure to make even more groundbreaking discoveries that will challenge our understanding of the universe and our place within it. The moon is a stepping stone to the stars, and the knowledge we gain from studying it will pave the way for even greater adventures in space exploration. The journey of discovery is never-ending, and the moon, with its enduring allure, will continue to inspire generations to come.